everyone. Today's video is about heterocyclic compounds and their naming. In my previous videos, do watch them. I have made for numericals and names and uses of lab apparatuses. So today it is about heterocyclic compounds. Let us start without wasting our time. What are heterocyclic compounds? They are compounds containing one or more atoms of other elements in addition to carbon. One will be a heteroatom. The name of this compound is pyrrole. Now, most commonly in the heteroatom used will be nitrogen or oxygen or sulphur. Most commonly, and we will be studying in detail about these, as well as they may be 5-membered and 6-membered rings. We will be studying in detail about these kind of compounds. There are other heteroatoms containing boron, phosphorus, silicon, tin, mercury, etc. But they are not very commonly used compared to these ones. Now, these heterocyclic compounds, before IUPAC nomenclature was introduced, we are going to study IUPAC of these kind of compounds. Before this was introduced, in earlier days, these compounds had common names or trivial names. These trivial names were according to the sources or of their characteristic properties. You can see here Picoline. It is a common name. In Latin, Picoline means tarry, picatus. Picatus means tarry. Tarry was derived from coal tar. So therefore they had this trivial name Picoline. Another one, furfural. Some more common names like pyrrole, furon, thiophene, pyrazole, imidazole. These are all compact naming system was modified along with this Hantzsch and Widman system, and then heterocyclic compounds have been named. Let us see what is the system first. To save the time, I have made this chart. You can see this. Now here, there are elements and their valencies. If it is oxygen 2, the prefix used will be oxa. Oxo. Ring means how many membered ring it is. The stem will be used, and these, whether they are nitrogenous or non-nitrogenous, depending on the saturation and unsaturation, the name is formed. Now let us see some examples, and then it will be very clear to you how this Hantzsch and Widman system is used along with IUPAC naming system. Now IUPAC naming system, the general method of using IUPAC naming system is, it has to have a root word or word root, it must have a suffix, and it must have a prefix. This was the general method of IUPAC. We have studied this method, this general method for naming any compound. Same this method is applied here also. This method is applied here also with some modifications. Here what is done, the prefixes that indicate the number of rings are combined with the stems. Which indicate the number of rings, and finally, like the prefix and the suffix, these behave as the prefix, and these stem along with this saturation and unsaturation will be used as a suffix. Now we get the word root from the stem. We will get the word root using the stem along with saturation and unsaturation. Now how it is used, let us see. If the compound that is given, if the heterocyclic compound that is given contains a nitrogen, then we check out this table. Nitrogenous ring system we will check out. If it is doubly bonded, we will see unsaturated. If it is singly bonded, we will see saturated. But if it is not having any nitrogen, if the heteroatom does not contain any nitrogen, then we will use this column and we will not refer to this column. That is the way this system is followed. Let us do some examples. We will be clear with how this system is used. Let us take an example of a 3-membered ring. This is a 3-membered ring. Word root word, we know it contains a double bond. So definitely it is ene. It contains 3-membered ring. It contains 3-membered ring. According to IUPAC naming system, 3-membered ring means that it will be having 3 carbon atoms. If 3 carbon atoms, directly we say it is propene. But here it is a heterocyclic compound. Therefore, we cannot use this kind of naming system. We cannot even use this kind of suffix. Suffix is used along with these things. Now it is a 3-membered ring. The first and foremost thing we have to see is how many atoms are present. The number of atoms present here are 3. 1, 3 atoms present. Therefore, we have to check out this. The ring system contains 3 atoms. So we have got ring system as 3 atoms. Then we check out what is the heteroatom present. Heteroatom present here is S. S is the heteroatom. If S is the heteroatom, it means sulfur. Sulfur prefix will be thia. So I will write down thia. The prefix is thia. 3-membered ring means it is thia. Next, how many double bonds are, what kind of bonding is present, whether it is saturated, unsaturated. We can see a double bond present, that means it is unsaturated compound. Unsaturated compound, we have found that it is a doubly bonded compound. Now doubly bonded compound, it is containing S. It contains S. It does not contain any nitrogen. Nitrogen is not present. Hence, we have to omit this table. We do not look at this table. Instead, we look only at this table. Now, non-nitrogenous ring system containing saturated, unsaturated. Here we know it is unsaturated. It is a non-nitrogenous system. It is 3-membered ring, and therefore, our stem is IR. Our stem is IR. Unsaturated ring, it is IRENE. So the name will be thiarene. We have got our name, it is thiarene. Okay, let us do some more examples. Let us take this example. It is a heterocyclic compound. It is a heterocyclic compound. It is having 2 similar heteroatoms. Both the heteroatoms are oxygen. Let us number how many they are. Numbering has to be done checking this priority order. Oxygen, both are oxygen. You can take the numbering from here or you can start the numbering from here. Just remembering that both should get the lowest possible number. If we number from here 1, 2, 3, 4, 5. If we number like this, 4 plus 1, we are getting 5. Let us do the other way around. 1, 2, 3, 4, 5. We are getting number 1, we are getting number 3. 3 plus 1 is 4. So this is lowest compared to this one. Therefore, we will prefer the numbering done with the blue ink. Now, how many atoms of oxygen are present? 2 atoms. So we can immediately write di. Next, how many members are present? 1, 2, 3, 4, 5. The ring is a 5-membered ring. So 5-membered ring, the stem word is ole. O-L-E. This is our stem word. We know 2 oxygen groups are present. Oxygen heteroatom, the prefix of oxygen heteroatom will be oxa. So we write down oxa. We got all the things. Where is the oxygen present? On number 1 and number 3. So we got 1, 3. Dioxa. Ole. Now we have to check this. This is incomplete because we did not check whether it is saturated or unsaturated. We have just got the stem. It is saturated compound, but it is not having nitrogen. So we refer to table which does not contain nitrogenous ring. This table we have to refer, and saturated ring. Saturated ring OLE, number 5-membered ring, it will be olane. So our stem will be completed with OLAME. So the name is 1,3-dioxyolane. Okay, now by understanding, it is difficult to write oxaolane. So we just skip this O letter and we write down oxalane. So our name is 1,3-dioxalane. In other things also we will do some 1 or 2 letters will be skipped just to make the writing easier. Let us take some more examples. 1, 2, 3 and 4. 1, 2, 3, 4. 4 means it is 4-membered ring. Now here next we do numbering. While numbering we have to be very careful because we have got 2 different heteroatoms. There are heteroatoms present but they are 2 in number. Now this numbering of heteroatoms depends on priority order. If the oxygen in this Hantzsch-Widman table, if oxygen comes at the top and nitrogen comes next, so numbering will be done from oxygen to nitrogen. Numbering, you will get oxygen as number 1 and nitrogen as number 2. Now let us name the compound. 4-membered ring. 4-membered ring, the stem word that we get, we do not use this kind of method anymore. Only prefix is there and then this word root and the suffix, they are all combined to form the stem. Now for the 4-membered ring, we have the stem as OT, ET. For the 4-membered ring, we have stem as ET. Next, 2 heteroatoms, we have got nitrogen present in it. If nitrogen is present in it, we have to see this table and not this one. Nitrogenous ring, whether it is saturated or unsaturated. Let us see, it is saturated compound. So saturated 4-membered ring, saturated it is ET. Okay. Next we have 1 oxygen and 1 nitrogen. Priority order, oxygen comes first and nitrogen comes next. So first we will write down oxa. And next we will write down aza. Okay. Oxa at number 1 and aza at number 2. Now the name will be 1, 2, oxaza etidine. Now here we can drop this A and finally what name we get is 1, 2, oxaza etidine. Okay, so we get this kind of name 1, 2, oxazatidine. Okay. Let us start the numbering from here. 1, 2, 3, 4, 5, 6, 7, 8. This is an 8-membered ring. 8-membered ring. 8-membered ring. Check the ring. 8-membered ring. What is the prefix? 8-membered ring. What is the stem here? It is OC. So we got the stem as OC. It contains sulfur as the heteroatom. Check out, for sulfur we use thia. Now this is saturated compound. It is not containing any nitrogen in the ring. Therefore we will omit this table and we will take this table. Now saturated 8-membered ring, we have the end word ocene. Got the final word thia ocene. Some more examples. Now I have drawn the figure. You can see here it is a 3-membered ring. let us find out the stem of this three-membered ring. Three-membered ring, the stem is IR. It is a heteroatom containing oxygen, so the prefix is oxa. It is singly bonded, therefore it is a saturated compound. It is not having any nitrogen, so we consider this column, and therefore the name will end with this irene. Oxairene. There is no need to give any numbering because it is at number 1 position, so which can be understood, and therefore the name here is oxirene. Let us see this ring. Let us see how many atoms are present. 1, 2, 3, 4, 5, 6. It is a 6-membered ring. 6-membered ring. Let us see here. 6-membered ring. It is the prefix here, 6-membered ring. The stem here is in. It is a 6-membered ring which contains nitrogen. Nitrogen, the prefix is aza. Next, it is containing 3 nitrogen present. It is having 3 nitrogen. 3 nitrogen means it is 1, 2. 2 means dia, 3 means tria. So it is triaza. Now let us do the numbering. Now let us do the numbering because if we do the numbering, 1, we have to also take into account the lowest possible number to this double bond. So 1, 2, 3, 4, 5, 6. So lowest locant that we are getting is, to this number we are getting 2, and this number we are getting, this nitrogen we are getting 4. So let us take 1, 2, 4. 1, 2, 4, triaza. Now we have got the stem in. These are unsaturated compounds. These are containing, in this 6-membered ring we get it as ine, I-N-E. So we will add it here, and our name is 1, 2, 4 triazine. Okay, this is our name. Let us do one more compound. It contains sulfur as the heteroatom. No nitrogen is present, so we will have to consider this. Now first of all, let us see the number of, because directly we can number 1, 2, 3, 4, 5, 6, 7. It is a 7-membered ring, so the stem will be EP. It contains sulfur, so the prefix will be thia. It does not contain any nitrogen and it is saturated, therefore it is epane. Drop off this A, it is thia. If you write INE, it will become unsaturated. Here it is saturated, therefore we write it as thia. By combining this Hantzsch and Widman systematic nomenclature and this IUPAC system, many different compounds can be easily named. Do try them on your own. Let me know in the comments, and thanks for watching. Do keep watching my video, subscribe and like my channel. Thank you very much.